Welcome everyone to session 6 of Terraforming Web3. This is our final session in the series. Today, we're diving into one of the most exciting intersections in tech, that of Web3 gaming and AI agents. We're joined by Loaf, the creator of Eternum on Starknet, and many other things. Loaf brings a lot of hands-on experience building at this frontier where fully on-chain gaming and fully on-chain elements in general meets artificial intelligence. So after Loaf's presentation, we'll have a little fireside chat to dive into the topics a bit further. In today's session, we'll just explore what AI agents actually are, why there's suddenly so much interest in them, and why fully on-chain environments are actually pretty uniquely suited for these types of agents. We'll also look at the current ecosystem and what the future might hold for AI agents in gaming. Whether you're already building with AI, developing on-chain games, or just curious about where these technologies are heading, I think today's session will actually help connect the dots for you and your project. So, Loaf, thank you so much for joining us today. The floor is yours.
Hey, hey. All right. Um, Apologize for my husky voice. I'm coming off a sickness, but I'll dive in. So yeah, the agents are coming. I actually tweeted this like 2 years ago, um, as just after GPT-3 came out, and yeah, it's taken longer than expected, but it's coming like a tidal wave. So I'm going to uh, I'm going to talk about like how I kind of see the current technology and like where I think people should be looking and some some really key data points you should watch out for that are really driving the uptake of this technology across the board. So you can think of agents as well. Firstly, one thing to get off the mark is LLMs, so large language models like GPT that you would have used, through ChatGPT or whatnot, or if you're a developer, you would use them through APIs. Any model, what they do is when they're trained, they take all of our understandings, all of our information, and they compress it down into a series of weights, just numbers basically. And so you can think of models as like these giant compression machines, and they allow us to then ask questions to them to give us answers. And you can take you know um, terabytes of information of raw data, and you can compress them down to gigabytes of weights, which then you serve them up through moles. And so you can think of them like it's compressed knowledge. And so what agents unlock this knowledge and kind of take it into like into the practical sense, and allow us to like leverage it, um, across all of our industries. Um, I'm having a lot of fun making these new GPT-4o images, so I decided to make a chalkboard. So what really are agents? So agents, I just told you what a large language model is. An agent really is just a model within a software loop. So don't get sucked into any like, crazy marketing terminology or anything. They're really just a model within a software loop. And so you take the response of a model and you feed it back into itself, and you attach tools to it, like APIs. You attach memory systems. Sorry, one sec.
I think we might have a few technical difficulties here. Bear with us. We'll get this sorted.
Sorry about that. Just need to get a drink of water. So yeah, you attach tools to them, memory systems, and state management systems, and that's what an agent is. So, but it turns out, um, you can go incredibly far with this. And so this is what ChatGPT is, right? You take a user input, you put it into a model, and you get an answer. And an agent is, you take an input, you feed it into the kind of agent software. It then can call a model, and that response from the model gets fed back into an agent. And then the agent can decide, doesn't want to call the tool, calls the tool, it returns it back to the agent core, and then it gives you a response once it's figured out, like, you know, what's it's trying to do. And it turns out this kind of architecture can actually take us incredibly far. And you can kind of see, I just pulled some of these kind of aggregations off the web. Um, but you can see like it's been an absolute explosion in these types of frameworks and kind of tooling and what around it, because they're incredibly useful. So and all of these things are really just, parts of this diagram, in a sense, or all of it. Um, and so the question is like, why now? So when I started playing around with agents a couple years ago, kind of like after GPT-3 came out, there were a lot of limitations. So one of the limitations was the context size of a model, which is really just like the kind of like how many words you can kind of consume in its memory at once. It was very small. I think GPT-3 was like 4,000 tokens, which is about 1,000 words or so. Um, they're also incredibly expensive. Um, and incredibly slow. Now, what's happened in the last 6 months is, we're no longer limited by that. The cost has come drastically down, and the speed has gone drastically up across all these metrics. And so this is why in the last 6 months, everything has just exploded. And so this is probably one of the most interesting graphs I think you can see right now. And so what is this is the context length of a model, kind of it's change over time since like 2021, and this is a logarithmic scale, and so you can see here where um, we're at about 1 million tokens right now as of the last couple of weeks, as kind of like the gold standard right now, and 1 million tokens. I'll come back to this because I'm kind of, there's a lot of numbers here. Um, But 1 million tokens is about two Lord of the Rings trilogies. I'm using Lord of the Rings trilogies as my metric here. And so, if you've never heard the tokens, heard of what a token is, this is kind of a good way to think about it. So, 1 million tokens is two Lord of the Rings. 10 million tokens is 20 Lord of the Rings. 1 billion tokens is 2,000 Lord of the Rings. I don't know, I think it's a pretty good metric. And so, yeah, a model's context window is like how much text it can see at once and understand and respond. It's like a short-term memory. And it's really important that this is like key to understand what like the capabilities of like how agents will progress over the next few years. And like one of the reasons why they've suddenly become useful is because of this single thing. Because if you think about it, like, you want an agent to be able to reason over lots of information instantly. And so the more information you can give it at once, the more reason it can do it at once, over something. And so, um, and it's like try to like equate like, you know, whatever you're doing, whatever you thought of, and like, in the agent space, or like if you've had an idea, like maybe in finance, think about like how many, um, you know, um, PDF documents, is equivalent to a Lord of the Rings trilogy. Like it's a lot. And this is only going to grow, exponentially as we go on, and so it becomes more and more useful. And another metric to consider is um, like how many tokens per second, we can process at once, and this is also going up at like a logarithmic rate. And so I did this like calculation a while back about like how much um, like what would it take to inference like all the data humans produce daily. Um, and it turns out humans produce about 40 petabytes of data daily. That was about 4 months ago. I don't think it's would have changed that much by now. But to inference, so to basically process all of humans' data that we generate daily with models, it would require a million chips running a million tokens a second, all, kind of, a variation of that. And with that, we could inference every bit of information that happens daily. And so if we come up with a cluster that can do that, it will understand everything about the world instantly. And so I always thought this was like a kind of a checkpoint in kind of, what you consider AGI. I don't think this is AGI, but it's definitely a checkpoint to get to that point. Um, and so yeah, this is a interesting statement. Imagine a world in the future where you could take all the daily trade data across all equities and futures and reason about it instantly. And like that is a reality that we'll probably be in within the next 24 months, which is kind of nuts to think about. And you can kind of extrapolate that to like every industry that you ever want to think about. But obviously, finance is pretty interesting. And same with, the whole crypto space and I mean, you could easily consume all the information across across the crypto space daily. You could probably do that now. Um, and then the final thing is like the cost of this. And so the the cost per million tokens is just dropping drastically as well. And it's dropping drastically as the quality goes up of these models. And so, we're at like GPT 4.1 mini, I think it was mini, came out yesterday, and it has a million token context window, um, and it is 10 cents per million tokens, which is insane. So that's incredibly cheap. Um, I actually haven't even used it yet. I haven't had a chance. But yeah, so this is dropping at a drastic rate. This graph actually doesn't even take that into account. So, but you get the idea. These are some very very steep curves that are all coming together, and um they're all like crucial in understanding like the usability of agents. And so another thing to think about as well is it will get to a point very soon where like the marginal cost of electricity will drop to the cost of electricity. So like literally just like the raw running cost of GPUs will be the cost of the model. Um, and you'll probably actually be able to run them at home as well. Um, like there are constraints in these charts. Like I'm extrapolating them a little bit. But the trend lines, until we hit this like a curve, I'm just going to accept them. I'm sorry, until we may hit a plateau, but until we hit that, um, we have to take them as the trend. And so, energy is actually a serious constraint, which a lot of like the giant labs are running into. I know Grok was like spinning up like diesel generators to like power their clusters. Um, and then, the like the raw like compute, like we simply do not have enough chips to handle the current demand. And then there's like the actual physics of the memory systems themselves, trying to, you know, I don't know, like the memory usage for context size like grows quadratically with its length. Um, well, that's what it used to anyway. But I think there's a lot of research in that area, and it is a kind of a deep rabbit hole to go down. But there are some constraints there. But anyway, um, this is just an energy use table as well. I've given you a lot of tables because I think it's really important to like understand like how like the these graphs like really dictate like how useful these agents are going to be, because they really open the scope of them. Um, yeah, so some more. So now the question is like, well, what are we going to do with these agents? Now, uh, of course, we're going to do gaming, which is most important, obviously. We're going to do DeFi, finance, and we're going to do productivity. But I'm just going to specifically talk about right now. I can't go into every absolute everything, every agent related thing. And we're going to talk about agents being used in Web3 games, specifically. So I kind of see agents as like um, they're just a tool in my toolkit when I'm building a game, or I am building a service for a game or whatnot. I actually have there's so many possible ideas to explore in this space. I haven't had a chance to explore all the things that I've thought about. And so I'm focusing on a few things. But I'll run through them. Um, so some of these things are like non-deterministic worlds where you can create a world where you as the creator um, don't, you know, don't fully know how the world will emerge, or how the world works. You just set up a few parameters, and a set up a few prompt. You basically make the world in prompts and let the model kind of create the world as it sees fit. You can create non-player characters that are like very emergent and realistic, and interact with players and whatnot. You can create emergent worlds that like where the players themselves um, like build out the world as they start playing it, and then other players can experience the uh, worlds that the other players have already like experienced, and so and you can do this because of like the model's nature, that they're very they can output results different every time, and so it really comes down to like the skill of like how you program them. And you can also create true roguelikes that are very non-deterministic and kind of like emerge as the players play them. And you can do game automation and whatnot. And so one of the games that I've been um, building for the last few years is called The Realms Eternum. It's a civilization style on-chain game. Um, uh, it's actually launching in about a few weeks on Starknet. And within this game, we have designed these daydream agents, which act as NPCs in the game. And so this is a map with a lot of daydream agents existing on it. But these agents basically you discover a hexagon, and there's a chance that a agent might spawn, and that agent, if does spawn, becomes its own kind of entity in the game. You can chat with it. You can try to convince it to attack another player, um, or you can kill it, and take its resources. And so this is going to be a crazy, wild experiment. I'm not quite sure the entire outcome of it, but it's going to be very interesting. And each one of these agents have like a generative personality. Um, so yeah, this is like the architecture of the daydreams Turnham agent. It's rather simple. I mean, there's like lots of guts to it, but this is really how it works. We every 10 minutes um I trigger the agent to kind of think about and reason about its surroundings. I pass in like a map of its surroundings, and it decides where it needs to move. And if it decides it needs to move somewhere, it can call the contracts, or it can search the map for other people, um, and it just kind of repeats. And so this could be replicated in other games. Um, and yeah, so um, kind of talked about world bosses. Um, uh, I think emergent worlds are very like are a really unexplored area. And as they like, this is the type of game that was very, very difficult to produce before LLMs. Actually, probably wasn't even possible. Um, but like, you can think of an emergent world type kind of use for an agent as like as the players start to explore the map, um, the agents kind of generate it as the players explore it. And then other players can kind of experience that part of the map that the other players have just kind of generated. And so you can kind of like this, like the game starts as nothing and it emerges into this kind of rich experience, totally kind of generated by the players and the agents as they play it. Same thing with roguelikes. Um, and then another thing is um, you can do game automation um, uh, as well using agents. And so here is an example of an agent playing this game called Gigaverse, which the agent kind of decides what it should do next and just plays it. Um, so what happens next? Well, I hope Dylan and I can talk about this. I haven't put too much after this because I was hoping that we could talk about this. But one thing will be I predict that all UIs will essentially disappear. Um, and everything will be natural language and voice. It's reached this point from all the economics that I just described that it's becoming feasible for this to be a reality, like everything. Um, Once everything becomes cheap and fast enough, then it normally takes over. Um, so yeah, that's
Awesome. Thanks, Loaf. That was a really cool presentation, actually. Um, and I know that you mentioned that we will be able to discuss a few things, what's next, and we'll dive into that quite a bit more. But just generally, thank you again. That was such an insightful presentation. I think there's a lot of stuff uh, related to AI agents that you mentioned and how we can potentially bring them into on-chain gaming. So with that, and what's next, let's dive a little bit deeper into some of these concepts. And I would really love to just explore your experience bringing them and building fully on-chain games in general, like Eternum. So yeah, I've got some questions. We can explore some of the theoretical concepts, and then we'd love to bring it back to some of the practical realities of building in the space. Cool. So I guess let's start off with some theory. For those of who are new to the space and maybe are skipping straight to the fireside presentation, would you be able to just quickly explain what AI agents are in plain language, and then more specifically, what makes them different from regular AI or NPCs in games?
sure. So well, a regular NPC in a game. Well, I mean, I guess it depends what game it was, but um, an AI agent is really a model that is wrapped in a software loop. And so if we're talking about NPCs, you can create an agent that has its own personality, it has its own ways that it can play the game because it's a non-player character. Um, but it exists in the world in a state that is uncontrollable by you as the developer. Well, controllable in the sense that you can guide it through your prompting, well, through its original prompting, but you don't really know what it's going to do. And you can give it as much scope or as little scope as possible in order to play the game, which allows it to become, its own kind of personality, and it can generate its own memories and kind of just exist in the world as this own thing that you can't really control. And so that's kind of that's very different from, NPCs from 10 years ago, where, maybe they had like very basic AI in them. But they probably had like a very basic decision tree baked in. They couldn't really do a whole lot of things, and they're very like rigid. And so, these new type of agent NPCs are, they're much more vivid and realistic, kind of characters.
So just diving a little bit deeper into that, I guess what specific advantages does an on-chain environment offer for within the AI field or within AI agents compared to the traditional infrastructure that isn't fully decentralized? Like why does it matter?
Yeah. So the beautiful thing about on-chain games is that they're the whole architecture of them is entirely open. And their APIs are all based on just a singular RPC endpoint. So like an API endpoint. And to interact with that endpoint, you have to send it a small piece of structured data. And that small piece of structured data is the perfect thing that an agent can generate. And so an agent is able to operate a like any on-chain game, without any extra infrastructure. And so that's why they're incredibly useful. If you counter that to like a traditional gaming environment, you would have to build a kind of like an API wrapper around the game itself in order for an AI agent to play the game. And so by the nature of on-chain games, just make it easy. So that's a huge, huge benefit, for the on-chain environment.
Nice. And then as you're thinking through how you're putting AI agents into Eternum, how do the, or just generally speaking in the on-chain gaming space, how do you think that these AI agents actually change the fundamental design approach to building games? And, I think that kind of goes along with what you were talking about, just, what new possibilities does it open up in terms of pure gameplay?
It's it's really an extra tool. Like you still have to design a game. Um, uh, But the like the properties of an agent is that, it's this entity that you can release to the world, or like you can put 1,000 into the world, or 100 or whatnot. Um, and it allows you to, well, yeah, I mean, there's so many things. I'm trying to nail down a specific one. Maybe, like if you're building like a PvP type game, like you could always have an agent that like you could have an agent that plays humans, and that agent's always going to be there. It's always going to play the humans. But it will play the game in a way that's actually very smart. And so my like goal of the next 3 months um, is to make agents play, Eternum end to end as just as a human would. And that's like an incredibly hard problem, to solve, because, the strategy games are very, very hard to, kind of reason about. But it goes along with like, as well, like, if that, is possible, if you're making a, PvP game, on-chain game, you can have an agent as the opposition for human players, that's always on, and the humans have to try to defeat them. Um, and so, it enriches the game world, and it just improves the user experience. Um, so you don't have to do like, matchmaking. So that's one big advantage.
Yeah, I think kind of the decentralized matchmaking, just in general for AI, is such a valuable thing. Like, what if you can have a decentralized Uber, but requires a matchmaker to connect riders and drivers, but bring it into the gaming world? I think that's extremely interesting. But,
Yeah.
mentioning this, oh, sorry, Liv, go ahead.
There you go.
Oh, yeah. So, you were mentioning just this concept of building agents as sort of like end to end as you would make a human in terms of strategy world. I guess there's such a deeply technical solution that requires more than just here's the technical aspects, here's the prompting elements. Here's like how you actually build an agent to represent a real human player. What are some of these challenges that you faced when
Mm.
actually implementing some of the AI agents in Eternum? Maybe you can give some specifics that you've
Yeah,
kind of come across and how you fix them or how you're thinking.
yeah, yeah. Good question. So the challenge with an agent is like like over a long period of time is its goal structure. So you need to like to win in a game like a tournament, you have to eventually generate enough hyperstructure points in order to press a button, basically. But in order to get the hyperstructure points, you need to first get the hyperstructure foundations. To get the hyperstructure foundations, you need to first, search the map for them. To search the map, you need to build an army. To build an army, you need to generate resources. Generate resources, you need to build, um, um, you know, resource building. So you get my point. Like there's like this kind of like hierarchy of tasks that you need to accomplish in order to win the game. And an agent needs to then in order for an agent to do that, it has to like define its tasks itself and then slowly work through those tasks in order to achieve the higher level task. So it first needs to build um, buildings in order to generate the resources. Then it needs to build military buildings in order to go and out on the map and not die, by other people whilst it tries to find the hyperstructure foundations and whatnot. It needs to trade on the market. It needs to do all these like small tasks in order to make up the big tasks. And just the fact of doing that and like how it stores its own memory, how it reasons about like what it should do next, that's the kind of technical challenge. Like it's very easy to get an agent to just like send a funny message on Discord or send a couple of messages or, a trigger or something. But to get it to accomplish a task over maybe a week or 2 weeks without it kind of like, getting stuck, um, is the challenge.
Nice. I'm going to repeat what you said earlier. You were saying AI agents are just a tool in your arsenal. Um, Frankly, you can use tools poorly, and it could lead to diminished player agency and engagement. Or you can use your tools positively to actually enhance the gameplay. And I think that's kind of the key thing here. There's so many challenges associated with it where you need to sort of think through how the AI agents will look, what its primary use case will be. And the goal is like actually doing it properly rather than just implementing it without a real care or thought to how it actually can change the player agency and engagement. And I think that's kind of one of the more technical and deeply, deeply difficult things because we've seen so many projects look to bring in AI agents, but use it as more of a narrative than actually something to benefit their product and the end users too.
Yeah, yeah, it's yeah, I mean like everything can be abused and hyped up in the wrong way. But yeah.
Yeah,
Um
cool. Perfect. Just moving on to a little bit just within Eternum too, how do AI agents interact with the in-game economy? And more generally, as a follow-up to that, what do you think are some of the new economic models that are created or are become possible with this type of new type of tooling and structure within fully on-chain games?
so the agents in this season, they don't trade on the market. They hold resources and you can steal resources from them and they'll burn the resources if they die. Um, but they're not trading on the market because I'm the next season they'll try to do more operations in the game, but this season they're really just kind of NPCs on the map that move around and try to kill people, or you try to kill them. Um, what was the second part of the question?
Yeah, just more generally, more theoretically, what kind of
Mhm.
new economic models do you think become
Ah,
possible within fully on-chain games?
um, I mean, I'm not sure. That's a good question. I think they just, they improve the game.
Yeah,
So, if you if you have a good model already based around your gameplay, then that the agents should be able to enhance it or improve like the user experience, which will then benefit your underlying model.
yeah.
Um,
Eh,
but yeah,
I think you touched on this, so I probably just overstepped a little bit, but I mean, you were mentioning how AI agents are going to be used this season and potentially in the future. I think that's just kind of a concept of putting them in and making sure that, if they're trading or, for example, in the future, potentially, you have to consider how it's going to balance the sinks and faucets associated with the game to make sure that, the AI agents are appropriately measured and
Yeah.
not necessarily changing up the way the game economy works.
Yeah, that's part of the fun of it, though. To be
Yeah.
honest, that's what is interesting about these agents is that they're non-deterministic deterministic nature. Is that like you don't really quite know what they will do, and if you set them up in the right way, they'll just kind of go on their own path, and they'll have this like emergent gameplay between each other. So my hope is that agents start killing each other, or they start ganging up against humans. I don't know, but that's part of the fun of it.
Nice.
I'll be
Well,
I'll be I'll be in the arena as well, trying to take them down. So yeah,
I feel like the AI agents will be be quite an interesting little clan in Eternum. You had a slide in your presentation of what's next. So what is next for Eternum? Can you give us a little shill for Eternum and what we can expect in store over the next couple months?
so this season is really like the first production release. Um, it it contains all these Daydream agents. It's it's been massively kind of re-engineered to like scale to like thousands of concurrent players and with excellent performance and whatnot. So as this season ends, this season might take between 4 to 6 weeks or so. Um, we'll the idea is that they the seasons run out every 4 weeks gap between them also. So with every season, there'll be a iteration in the agent design. There'll be an iteration in some of the gameplay and some of the ways that you can win the game. And so we'll just be keeping layering up experiences within the game world, and also like the compatibility with other game worlds that can kind of be injected into the hexagons and whatnot, which are where we will be experimenting with this season as well as actually. Um, but
So what does that mean? Compatibility with other game worlds.
so there's a chance to kind of open a portal into another game on some of these hexes. And so you get this natural composability across on-chain games.
And that's only possible because everything is built on chain. So you can
Yes.
actually, yeah, that's
Yeah.
interesting. That's really cool. And would the AI agents in Eternum be able to potentially participate in the worlds that are opened up on a particular hexagon?
See why not? Maybe not this season, but yeah, in the next season. Just yeah. Yeah.
That's really cool.
Yeah.
Nice. And I guess, just getting back a little bit more to the game developer side, um, how can people listening to this talk that are interested in putting AI agents into their game, how do they get started? And then after they get started, how can these developers actually bring community participation to actually start training or evolving their AI agents within their game itself?
Well, I think firstly you need to figure out like, how you want these things to kind of play your game. Um, and how they're going to exist in your world and build them. If you want to build one, reach out to me. I can definitely point you in the right direction, um, and some kind of code examples. Mm. So yeah, I mean, I just kind of dive in, try to get them to work, and then let set them free.
Cool. And I have my last question before just opening it up to Q&A. Where do you see AI agents in on-chain gaming in the next 2 to 3 years? What areas do you think are still underexplored, and what areas do you want to start seeing, especially in what you're building with Eternum?
Um, I think just going down this path of agents existing in games and enriching the game worlds. Agents will get better. They'll become on par with humans. It'll become more macro style games where you're commanding maybe legions of agents to play these games against other legions of agents controlled by other humans. And so we'll become the puppeteers of all these agents, or maybe the agents will be puppeteering us. I'm not sure. Yeah, it's hard to
Yeah.
predict. One of my other I've dropped a lot of like kind of philosophical points in this slide deck, but one of the other things that I think about, which I think people I find interesting, is like if you were to say in 2005, try to predict 2020, what the world would be like. I think you'd be able to like roughly predict it, like advancements across like information technology. Um, you know, it, there wasn't any like it would have been easy like kind of um, there wasn't like any like major kind of technology change that would have like was very hard to like predict. That would have been obviously you wouldn't have got it entirely correct, but like I think people predicted it roughly correct. Now, if you take where we are now and try to predict in 2045 based on what we know about AI, I think it would be like it's insanely hard to predict because of this like oncoming wave of AI and like the total destruction. Maybe destruction is not the right word. The total like um, changing of our society because of these tools. Um, I think it's incredibly hard to predict past out like 2029 when these kind of like curves start going like crazy exponential. So yeah, I don't know. But it's something that I think about. Um, but yeah, I don't, in 2 years' time, I'm not sure, but I think it was only 2 years ago that GPT-3 came out, by the way. But so in 2 years from now, I think these AI systems will be incredibly good. Um, maybe Eternum's in season 10. Um, yeah, I don't know.
That's yeah,
Yeah,
that's sort of the beauty of building on this frontier tech. It's
yeah,
you have the opportunity to change the trajectory of it. And there's a lot of things that can happen. And what you can envision 10 years from now could actually happen tomorrow.
yeah.
And sometimes the opposite happens too, and it doesn't develop as quickly as you want. But I'm super excited about this space, AI in general, and I think that my whole thesis around gaming is that gaming is the app layer for all the new type of technical innovation. It's something that I've mentioned a few times during Terraforming Web3 sessions. And I think AI is just one of those tech pieces that gaming will really push into the
Exactly.
mainstream in
Yeah.
terms of how to use it in the application itself. So it's
Mhm.
very exciting.
Yeah. It's always the leader in technology gaming.
Yeah, nice. Well, thanks for the great chat, Love. I'll open up the floor to questions from the audience. So anyone who has questions about AI agents, on-chain gaming, Eternum, anything we've discussed today, please feel free to ask in the comments below. We do have a couple quick questions. So Luis asks, how do you control the cost of AI generation for UGC? Tiers or by transaction? Do they impact speed, performance, or user experience?
I control the cost of AI generation on. Um, yeah. So if we're just talking about like text, um, I mean, I'm assuming you're referring to like within Eternum. Um, I, I try to like I've like heavily optimized um like how much a call costs like what an agent call costs, so that really minimizes it. If you're not careful of like how much, like context is still quite expensive. It's like if you're just shoving absolutely everything in every single call, it's incredibly inefficient and it costs a lot. So it's really just matter around like how efficient you make your agent. um
Nice. Cool. Luis also has an interesting question. As a developer, how can you control the lore and progress of the game story when AI agents act on their own?
I don't think you're meant to. I think you just like that's the point. is that the agents, the story is meant to go, and it's the path that the agents are meant to, that the agents want. That's the beauty of it. So, um, I think you can point them in the right direction through prompting, but ultimately they might not 100% listen to you. So,
Yes. And then last question from Luis. How do you detect and avoid bots slash AI agents to take advantage of the economy of the game now that they will act as quote unquote humans?
yeah. So I think that this is the other great thing about on-chain games is that you can't bypass the physics. So agents can't bypass it, humans can't bypass it. And this is the important thing of when you are designing an on-chain game, is that a digital kind of being that can't use its advantage on over a human. And so like it obviously an agent's advantage is that it doesn't have to eat, it doesn't have to sleep, it can act at the speed of light essentially. And so you need to limit those can those parameters of it. Um, and so Eternum as an example, if an agent is trading on the market, well, it's trading on the market. If they think of a better strategy, an arbitrage strategy, they can do it just like a human can. So yeah. So I think it's a matter of also every trade in Eternum is like rate limited. Like you have to it takes t time to arrive to you. Like you can't do high frequency trading. So like you can't just arbitrage what high frequency trading bots do, which is like the advantage that humans can't do. So it's really just putting humans and bots on the same playing field.
Amazing. And that's it. We do have a quick question from OX Genius. We'll get to that very quickly. But that does wrap up our final session for Terraforming Web3 series. Loaf, really huge thank you for sharing your experience, your vision for AI agents in Web3 gaming. Can you share where we can find you and learn more about what you're building with Eternum? And to answer OX Genius's question, is Eternum Season 1 going to be on testnet or mainnet? Could you give us a little shill for Eternum and where we can play? Of
Mainnet, of course.
course.
Of course, mainnet.
I wanted that
Um,
quote. So,
yeah, of course. Um, yeah, so you can find me on in Discord or on X, um, where I share updates on agents and Eternum all the time. Eternum is kind of in its final stage right now of ramping up, so watch out for the announcements around that. Um, yeah,
nice. Well, again, thank you so much, Loaf. This has been awesome. I always love every conversation that I have with you, and
likewise.
I'm super excited for Eternum. And for those looking to continue their Sarknet journey, first one is Cairo Basecamp. It's the best way to get up to speed with the Sarknet stack. It covers architecture, tooling, literally anything, everything that you need to start building. We had a nice little session that we've had a few of them already, and it continues on Thursday tomorrow. Also, you should check out Founder Basecamp, especially if you're a non-technical person looking to join an incubator style program to refine your startup idea or perfect your pitch or just get investor ready. We had session 3 yesterday. Session 4 is next Tuesday at 4 p.m. UK. That is covering how to tell a story and how to pitch. Yeah, that's it. That concludes Terraforming Web3. We've had 6 amazing sessions. Honestly, thank you to all of those who watched every one of them, for all the speakers who have participated throughout these sessions. Um, Honestly, for anyone watching live or watching the stream, we're super excited to see what you build on StarkNet. And thank you again, and we'll see